What's up? It's your boy the Canologist. We're back. Another episode of Code Study Sesh and AFK OSRS training. Okay, we're going to be doing mutexes in Go. Okay, mutexes allow us to lock access to data. It's like I gotta resize this thing I just made. Okay. Lock data allows to lock data. Lock access to data ensures that we can control which Go routines can access the data at which time. Okay. Let's check that out. Ensure that we can control. Allows to lock access to data. So let's put that lock. Control which Go routines can access data at which time. So Go's standard library provides a built-in implementation of a mutex with the sync mutex type. Okay. Lock and unlock. Sync mutex type. Lock and unlock. So this is built in Built-in Golang. Yo, what's with these shit fishing spots? Why does it keep fucking stopping me? We can protect a block of code by surrounding it with a call to lock and unlock as shown in the protected function. I need to understand why things work the way they work. So there's lock and unlock, two separate methods. Okay. Okay, it's good practice to structure the protected code within a function so that defer can be used to ensure that we never forget to unlock the mutex. Okay, that makes sense. Because if we lock something, we do want to be able to unlock it at some point. So now that we know that, we want to protect the function. So we call it in a function so that we lock it and defer the unlock. The rest of the function is protected. Any other calls to mu-lock will block. Mutexes are powerful. Like most powerful things, they can also cause many bugs. Okay. Maps are not thread safe. Let's figure this out. Maps are not thread safe. So thread safe functions thread safe when it can be invoked or accessed concurrently without causing unexpected behavior. The program executes several threads simultaneously in a shared address space. Thread safe is basically when data can be accessed simultaneously by multiple threads So yeah, let's look at this. Mutex maps are not thread safe. Maps are not thread safe for concurrent use. You must lock your maps with a mutex. Must lock your map with a mutex. We sent emails across many different Go routines. To keep track of how many we've sent, we use an in-memory map Okay, so that's part of the assignment. Our safe counter struct is unsafe. Update the increment and val methods so that they utilize the safe counters mutex to ensure that the map is not accessed by multiple go routines. WASM is single threaded. I know WASM is also known as WebAssembly. I believe that's what the term is, WASM. It's worth pointing out that our execution engine, root.dev, uses WebAssembly to run the code you write in the browser. WebAssembly is single-threaded, which awkwardly means that maps are thread-safe in WebAssembly. I've simulated a multi-threaded environment with the slow increment and slow val functions. In reality, in any Go code, you may or may not run on a single core machine, so it's always best to write your code so it's safe no matter which hardware. Well, that's fair. You want to create a generic, robust program that will run on anything, right? Code reusability, code versatility. These are things we strive to uphold. When creating good quality code, so let's figure this out. Maps are not safe for concurrent use. Okay, that's fine. This is a safe counter. Okay, so this is a method of this struct, I guess. Func sc safe counter. So this struct has a safe counter method, and it's got a function called inc, which takes a key string sc. Well, since it's already, we want to lock it. So we can go mutex lock. Sync mutex is mu. So we can go mu.lock. Defer mu unlock. So I would have had to go sync mutex, but since it already has it in the struct, I can just call sc sc mu lock and then sc this points to the mutex within this struct, so that's why I have to refer to it. I guess it's the same thing, so update the inc so that the values are easy. So I just defer lock and unlock on both. And why does this work? This works because of the following principle. I'll show you guys. I just gotta add the example to my notes as well. I'm gonna add this. Basically what this is this protected function encloses the whole functionality of your Go routine or whatever. Concurrent, where is it at? Protected code within a function. If we want to protect code, let's say we want to access something and we want to protect it, we have to lock it and then unlock it. The way we lock and unlock it is scoping. So the function encapsulates the scope of this block of code, and the lock and defer unlock basically says lock this code till it's done, then defer. So this means defer means once this function is done running, then unlock it. And that's what we're doing here with this function. But yeah, that's pretty much it. Let's also explain this. Guys, submit this. Should be correct. Yeah. Basically, I take grasp the mutex protection perfectly. By using the SC mutex lock, basically he's saying, so let me drop these fish. Yeah, so by doing the mutex lock, basically, and defer unlock, right after you create a protective barrier around the critical sections of the code. The defer keyword is particularly elegant because it ensures the mutex gets unlocked when the function exits. So basically when I run the code and the function exits and it's done, then I unlock it. And this is the pattern. Mutex ensures that only one Go routine can access counts at a time, preventing race conditions. So if two functions want to update a value, let's say the value is 3. Like, I just want to share my screen. So this is the mutex code, but let's say two functions. And there's a val 3. This is going to update val 3 to, let's say, 4. This is going to update it to 4. But technically, this value would be changed due to this one. So all the stuff here, this would create a race condition because this thinks it's still 3, but it's actually already 4, right? So we want to avoid stuff like that. So what we do is, we use this mutex. So that way only one Go routine can access that function at a time. And Go routines are basically just concurrent functions that want to access or run on their own. that run on their own independently, basically. And then yeah, when you try to increment preventing race conditions that would otherwise corrupt your data when multiple go routines try to increment. You've successfully transformed unsafe data into a thread-safe one. This is called thread-safe because multiple go routines, and like we mentioned in previous videos, go routines aren't specifically threads, but they tell the operating system to create threads. So you're indirectly creating multiple threads. You're doing multi-threading basically, right? But when you run two go routines at the same time, right, we want to make sure both of them don't access data that's supposed to be incremented at the same time. So that's why we create the locks. That way when this channel is done or this go routine's done, then the next go routine can access it without corrupting it. Try to increment simultaneously. So yeah, successfully transform this into a thing. Fundamental pattern you will use when building concurrency. So this is probably because Go is based on concurrency, basically. The whole benefit to Go is using the Go routines. It's just built in. It's easy. You can just add Go to it. There's no verbose syntax. You don't have to actually talk to the operating system. It's all handled by Go. You just have to define the functions that you want to run in a separate process. And with that, we've also hit 62 phishing. So let's go to the GE. Once I get a full inventory. And meanwhile, let's look at this. Mutex is a short form for mutual exclusion. Let me add that to my note as well. Nice. Name for the data structure that provides is mutex, often abbreviated to mu. It's often called mutual. It's called mutual exclusion because the mutex excludes different threads from accessing the same data at the same time. So mutual, we don't want to both. You know when someone says they fucking broke up or some shit, they're like, it was mutual, we both wanted that. No, we don't want mutuality when it comes to Golang and mutexes. Mutual exclusion is like, we both know, just I wanted this. So it's basically called mutual exclusion. And then let's see what other questions. How many threads can a mutex lock at once? It would be one thread, it should be. It should be a mutex per thing. Shared resources. Wait, release. 2 threads. Infinite. JK, it should be just 1. There we go. It's not infinite. Just wanted to show you guys that it can't be infinite. Alright, mutex review. But yeah, that was a really good analogy. If you imagine a breakup as a value, and you're mutual, that means both you guys at the same time wanted this shit, which is not possible, right? So the mutex says only one at a time. So this guy gets blocked, and then when this is done, this guy gets blocked. Well, and this guy's accessing. Function helps us avoid concurrent read-write problems. This problem arises when one thread is writing to a variable while another thread is reading from that same variable. Mutex example, map int, write loop, read loop, okay, cool, block, make transstruct, get value from channel, so extract value from channel, program for exiting must be killed, write loop. So this is running in its own sub process. This is the main go routine. Main is the function. This is the sub go routines. Both of these are running at the same time, and block. Make transstruct. This is a channel structure. The example above creates a map and then starts 2 routines which each have to access the map. One consistently mutates the value stored in the map while the other prints the values it finds. We run the program on a multicolor machine. We get the following output: fatal error, concurrent map, duration, map write. Go isn't safe to read and write to the map at the same time. Why? Because maps are not thread safe. Mutex is to the rescue. Okay, cool. So now we have this main import sync mutex mu. We create the map. So this is the read and write loop. So now we've locked and unlocked. So whenever we want to add data to the map, we have to lock it, add the data, and then unlock it. And then we want to, when we do the reading of the map, we want to lock it, read the data, unlock it. In this example, we've added sync mutex named mu to the write loop. And then it's done. This lock unlock sequence ensures that no other threads can lock the mutex while we have it locked. Any other threads attempting to lock will block and wait until we unlock it. The reader, we lock before iterating over the map. Otherwise, and likewise, unlock when we're done. Now the threads share memory safely. So now you can't write while we're reading shit. And that's the important part. Another mutex review, but we will continue this in the next video. So stay tuned. Peace.